Hey there, folks. How you doing? Today I want to talk to you about igneous rocks. The word igneous comes to us from Latin, the word ignis for fire. You may be familiar with that prefix in a handful of words like ignite and ignition. Probably a few others that aren't coming to mind at the moment. Looking at this lava flow, it's easy to understand where they could think this was liquid fire, flowing fire, whatever you want to call it. Heck, practically anything that it came in touch with would instantly ignite. So, while they didn't fully understand where it came from, or what it was, they understood that it came from inside the earth. They may have had Vulcan in his forges, and a variety of other myths depending on where they lived, but we realized, at some level that this was coming from inside of the earth. And probably as we watched it cool, we realized that it turned into rock, and perhaps it looked like some of the rock around the area. Lava tends to, eruptions tend to happen with some, reoccurrence. So they may have even started to put it together and realize that some of these rocks around them were formed from this material. But it took us a long time to put it all together, and heck, we're still working on understanding how this all happens. So what specifically is an igneous rock? An igneous rock is a rock that forms from minerals that have crystallized in cooling magma or lava. So you take that magma, you take that lava that we just saw, you let it cool, and one by one little mineral grains will start to grow. Little crystals will start to form. This can also happen inside of the earth. It doesn't just have to happen at the surface. Believe it or not, it can cool inside the earth. It takes a lot longer. All right. So anyhow, igneous rocks can form at the surface of the earth or inside of the earth. Before we get any further, I just want to remind you what lava and magma are, what the names mean. Okay, they're essentially the same thing. It's just that when it's inside of the earth, geologists refer to it as magma, and when it's at the surface of the earth, they call it lava. But otherwise, it's just molten mineral mixture, as I like to say. Basically, it's liquid elements. Now, as you may recall, hopefully, from the definition of a mineral, all right, until it crystallizes, it's not technically a mineral. So you can't really say that there's minerals floating around in lava or magma. It's just elements. Remember those formulas, right? So this all starts to piece together. Those elements make formulas. Those formulas, when they crystallize, they become minerals. And then, by the time we're done, hopefully you'll understand, at least by the time you're done with lab, you'll understand that these different igneous rocks are nothing more than common assemblages of minerals that we've come to recognize and give them a name. Granite is really just a grouping of orthoclase, quartz, and some feldspars. All right, and they just agreed to call it granite at some point. Anyhow, I don't want to get too ahead of myself, but right now, just important, difference between lava and magma is lava is the surface, magma is inside the earth. They're both molten mineral mixtures composed of elements. Okay, so I'll talk about two main types of igneous rock. We've got intrusive igneous rocks and extrusive igneous rocks. All right. Intrusives, as the name might imply, crystallize inside of the earth. Intrusive, inside, interior. Get that in prefix there. So because they form inside the Earth, they form from magma. And as I indicated, they cool rather slowly compared to rocks that form at the surface of the Earth. All right, the Earth acts as an insulator, sort of the reverse of a cooler. A cooler keeps things cool long, right? Your beverages in the summer. But an insulator keeps things warm longer. But they do still eventually cool. Now, here's the important bit. And this is how you're going to recognize them. Because they get to take a long time to grow, these crystals do, they grow very large. What we're going to refer to as coarse-grained. Okay? Now, the proper term, and I'm trying to get better at using this proper term here, is phaneritic. Phanero, the prefix here, at the beginning of this word, means visible. So visible crystals, and you're going to see it in an image in a moment that shows you what I mean by that. All right. So intrusive igneous rocks are large-grained or coarse-grained because they take a very long time to grow. These are also called Plutonic rocks. You see that in the text. I hardly ever refer to them that way, though, myself. Trying to, as I said, use the word phaneritic, but usually I just say coarse-grained. So you see in these rocks how we can see the different colors, at least in these first two specimens. This one, you can see some color variation. All right. You're just going to have to trust me for a couple minutes on this one. If this were a fine-grained rock, you wouldn't be able to see the individual colors. You wouldn't be able to see the, believe it or not, that's supposed to be pink. The pink, the gray, the white, the black. There's even some clear sparkly in there. The quartz. Okay. Coarse grain means that you can see the different colors when stuff is different colors. The problem with this gabbro down here, most of the minerals in there are dark colored. Remember with when we did the mineral ID tables, you had light colored and dark colored. All right, well, these guys contain a lot of stuff from the light colored tables. This guy has got a lot of stuff from the dark colored tables, and it's hard to tell in this image, at any rate, that it's coarse grained, but you can see some texture in there. So that's what coarse grained means, okay? Extrusive igneous rocks, on the other hand, extrusive, external, extrude, again, prefixes. All right, a lot of that today. These crystallize at the surface of the Earth, so they form from lava. And because they're at the surface of the Earth, not insulated inside of the Earth, they cool rather quickly by comparison. Okay? I don't really have a time for intrusive cooling, but extrusively this stuff can cool within a day or two, if not hours. As such, okay, the crystals are very small, fine-grained, and we've got another prefix. We've got a prefix on a prefix. We told you phanero just a moment ago meant visible, right? Well, what does A mean as a prefix? Atypical, anomaly. Means not, right? So aphanitic means not visible. These are sometimes called volcanic rocks. I say that, but usually I'm fine-grained kind of guy. Okay? So, by example here, these aren't the best examples because you can still see colors, but hopefully you realize that, especially in this one, okay, crystals are significantly smaller. This andesite, the basalt, okay, if you look not at the lighter specks there, but in the dark stuff here. All right, these crystals are very, very small. What I usually say in lab when I talk to you guys about this is look at your pencil or your pen, whatever you have in your hand. It's the difference between the point that you write with and the end that you erase with, or where your cap goes. Okay? Coarse-grained is the eraser end. Fine-grained is the writing end. So, not visible crystals is a stretch, but the idea is that, again, because these cool at the surface of the Earth, they cool so much more quickly. They just don't have a chance to get very big. It's like growing lettuce or cabbage, right? The longer you leave that head of lettuce there, the larger it will grow. Now, there is a third type of igneous rock. It's kind of a hybrid, if you would. And it's called porphyritic. It's a weird-looking word there. A lot of consonants in that word. Porphyritic. And what a porphyritic igneous rock is it's a mixture of intrusive and extrusive activity. The rock starts to grow. Crystals start to form inside of the Earth. And then for some reason or another, that material gets caught up in some exiting magma. In other words, going to be lava at the surface in a moment. Those crystals flow out to the surface, suspended, kind of like chocolate chips in pudding, all right? And then the rest of that lava around it cools as an extrusive igneous rock. So you see, we have this word here, fine-grained matrix. Matrix is the background, right? Just like the movie, okay? So you've got this fine-grained rock with large crystals. Those large crystals happen to be the porphyrs. That's where the name porphyritic comes from. So you've got porphyrs, large crystals suspended in a fine-grained rock. It's going to look like a mixture of coarse and fine-grained because it is a mixture of extrusive and intrusive. Let's see if I have a picture of it. All right. And maybe you can see why I keep referring to it as chocolate chips. I call this the chocolate chip cookie rock in lab. So these dark crystals here are your porphyrs. They're not always dark, just I grabbed one that kind of looks like ours. And then this fine-grained rock, this fine-grained matrix behind it. So this is actually classified, well, jumping ahead of myself here, but this is classified as an extrusive rock because the majority of the rock is fine-grained. You follow? When it comes time to put a name on these guys, we look at, what the majority of the rock looks like. So this is a fine-grained, extrusive igneous rock that happens to have some large crystals, porphyrs, inside of it. So it would get a extrusive name. Okay, so I was kind of doing this without actually telling you about it. Igneous petrologist. Petrologist is someone who study rocks, all right? There's name beyond geologist. Geologist is geos, that's the earth. I study the earth. Petrologist studies the rocks. Anyhow, there's two primary criteria that they use when they want to assign a name to a rock. They look at the texture or the grain size, which is what we've been talking about to some extent. There's a few more you'll actually see in a moment. And then they also look at the mineralogical content, which I mentioned a couple times as well. So what I was really laying the groundwork there for is a lot of what you're going to end up doing in lab, and we'll definitely discuss in lecture. So two primary criteria are texture and mineral content. So, as I said, we've talked about much of this already. Igneous rock textures. We've got phaneritic, visible grained, coarse grained, okay? And reminder that these are intrusive. We've got aphanitic, not visible, fine grained, and these are extrusive. And I could guarantee you that there'll be a couple questions on the test that ask you about grain size, location formation, and what intrusive and extrusive mean. Please, those last couple slides, spend some time looking at them, okay? We also talked about porphyritic, that porphyritism was a mixture, okay? That leaves us two words, And what I don't have a slide for, but what we will mention in lab, is that they further break down igneous rocks into crystalline and non-crystalline. Like, what the heck does that mean? Well, these first three here are what they would consider crystalline igneous rocks. Okay? These bottom two fall under what they call non-crystalline. They're basically extrusive types, which is why they're listed afterwards here. All right, basically under extrusive. I'm sorry, these last two. I hope I didn't say last three. These two guys here, vesicular and glassy, all right, are basically extrusive type rocks. Vesicular means that it has vesicles. That's helpful, right? A vesicle is a hole, a pocket. You'll recognize it in a second, don't worry. And then glassy means, of course, glassy. All right. Oh, that's not the best vesicular picture. All right, so here's coarse-grained. Here's fine-grained. Here's your porphyritic. Here's your vesicular. Think of pumice, all right? Almost everyone knows what pumice is. It's got those little holes in it. Some of you even know that pumice is supposed to float and so on and so forth. All those little holes are pockets, all right? It forms from, as we said, from lava. And what happens, it's an extra gassy lava, if you would. And as the bubbles are popping out of it, think about the last time you poured yourself a glass of root beer, okay, and you get that nice head forming on top. That's formed from the gas escaping out of the root beer, right? Well, the same thing happens here. This gas is bubbling out of the lava, but as it's hardening, those bubbles stay there, or at least the pockets where the bubbles used to be. So you end up with this frothy sort of material. And again, picture pumice if you can. I thought that would enlarge a little better than it did. And this one here, I didn't pick a typical, piece of obsidian that you've all seen 100 times. I picked a really cool one that's got some oxidation in it here. There's also like snowflake obsidian that's got little ash marks in it. Lots of cool obsidian, but you're used to obsidian being black and glassy, and hopefully you can get the glassy nature here. You see a little bit of reflection. It's very smooth and glassy. So these are non-crystalline. All right. And your book will go on about how technically there aren't any minerals present in here, so we could only talk about elements. But for those igneous petrologists, it's a big deal. For us in a introductory level class, again, we'll just nod back to the idea of definition of a mineral, that mineral has to be crystalline. So therefore, if there's no crystals present in these rocks, technically speaking, there's no minerals present. Gabish? Okay. So these are your 5 textures. Phaneritic, aphanitic, porphyritic, vesicular, and glassy. All right, I'm going to end this one here before we switch to mineralogy. And, alrighty. Now, mineralogies. We recognize 3 mineralogies in here. Felsic, mafic, and intermediate, which is actually a blend of these two. In your textbook, you'll see others. And if for some strange reason you're out looking around on the internet or in some other books, you will see others. Excuse me. We'll just keep it very basic and simple right now. You'll also catch me referring to these as flavors of igneous rocks. They're made up of different ingredients, different minerals, right? So I imagine if we ate rocks that they would taste differently because of that. So, Felsic and mafic and intermediate are classifications based on the mineral content of the rock. And we've got this horribly boring looking diagram. It's going to be very similar to what you're using in lab, actually. So this is why I do use it in here. Down here at the bottom, we have our three categories, and these are vertical categories we're looking at. All right, and you see even on here there's an extra one, ultramafic. We're not going to worry about that. Mafic, intermediate, and felsic, which they also call silicic. I don't use that word. It sounds a little dirty. They say silicious. Silicic. Anyhow, we say felsic in here. It's referring to its high silica content is why they use that word. So we're going to ignore these arrows for right now. And we're going to look up here at hopefully some mineral names that we recognize. So felsic igneous rocks are made up of quartz, potassium feldspar, sodium-rich plagioclase, and biotite. And I know, wait a minute, you're saying, hey man, I thought you said we were going to use some names that we know. I only recognize quartz and biotite there. This is albite, and this one is orthoclase, because these are very chemistry-based concepts. They are going back to the ingredients. All right. You see calcium-rich plagioclase over here, and ferromagnesians. It's a lot of chemistry stuff. We keep it simple, as I said. So, going back to this summary, felsic igneous rocks are made up of quartz, albite, feldspar, orthoclase feldspar, and some biotite. Now, that we can understand. And in lab, we're going to remind you that these guys were all different colors. So you would basically be looking for a rock with those colors in it. You follow? All right. Mafic igneous rocks are made up of calcium-rich plagioclase. We don't know what that is. Pyroxene. We don't know what that is. Amphibole. We don't know what that is. Olivine. Oh, we recognize olivine. There's even some olivine over here, too. Again, names that we use. Pyroxene is augite. Remember augite? Okay. And amphibole is hornblende. Don't worry, in the lab book, we fixed this. Mineralogists and igneous petrologists, I don't know, they're two separate breeds or something. They, you know, in a mineralogy class, you would certainly be tossing around these words, okay? We're not in mineralogy class. We're in introductory geology. Even in the mineral chapter, they talk about hornblende and augite and orthoclase and albite, okay? But for some reason, when they switch to the Igneous Rocks chapter, they go back to these highfalutin terms, and it's always annoyed me. But I've looked around at a whole bunch of other different, you know, lab books out there and textbooks, and they all keep these terms in the Igneous chapter. It's just the way they do things. So that's, again, where us teachers come in, translate for you guys, distill things down for you.